This presentation covers a brief history of choice-based conjoint. It's focused on what users of research need to know. We're going to cover the first choice-based conjoint, what happened when a none choice was added, a dual response none, and then look at analyses and look at aggregate logit versus hierarchical Bayes, and then see what's next in choice-based conjoint. Check out our website, elucidatenow.com, for a wide range of content. So marketers started using choice-based conjoint in the late 80s, gained popularity in the 90s. And here's a typical choice-based conjoint card. We might call this CBC 1.0. Typically, a respondent might see 8 or more cards like this. The cards are presented in experimental design, so there's balance between and independence among the attributes and levels. Then early on, a none choice was added to gauge preference a little more accurately and give respondents an out. Thereafter, the concept of a dual response none was introduced. And the idea was that when we had a none choice up with the product choices, it was good for the respondent, but we were losing valuable data when they didn't choose one of the 3 product choices. So by placing the none choice after the product choices, we capture the full data about preferences for attributes and levels making up the product, and we also capture information for our none parameter. Let's call this CBC 1.2, and by many people, it's considered the best method for basic choice-based conjoint today. Now, moving to analyses, imagine that you have 2 brands of smartphones, Apple and Samsung. Half your sample likes Apple, doesn't like Samsung. Other half likes Samsung, doesn't like Apple. Well, if we use aggregate logit, it will tell you the brand is not important because it only models the average respondent. So aggregate logit was the original method used to analyze choice-based conjoint data. And as the name implies, it aggregates all respondents together, ignoring potentially useful individual respondent differences. Additionally, it has an assumption called IIA, independence from irrelevant alternatives. Having an assumption means the stats work best when this rule is met. And the issue is that this assumption is frequently violated when using aggregate logit to analyze choice-based conjoint data. The classic case is called the red bus, blue bus problem. And when a model assumption is violated, that's a problem. It reduces the accuracy of the model. So aggregate logit has been on its way out since the 2000s, so we don't recommend using it. So hierarchical Bayes is the gold standard for analyzing choice-based conjoint data. Introduced in 95, mainstream by about 2000, and it embraces respondent uniqueness by creating individual level models. The benefits are that it captures that respondent heterogeneity, we've got better model accuracy, we have the ability to run models on small sample sizes, and we can carry forward conjoint results into segmentation analysis. Originally, HB wasn't used because it was very computationally intensive, but processing power has accelerated so much in recent years that this is no longer a problem. You're doing conjoint because you want the most valid results possible, use HB. What's coming next in conjoint? Well, check out our video on adaptive choice-based conjoint, which looks at how personalizing the trade-off exercise can make conjoint even better. So if someone's trying to sell you a conjoint project, ask them if they're using aggregate logit or hierarchical Bayes for the modeling, if you can offer respondents a dual response none option, and could the project benefit from an adaptive choice-based approach? Again, we have a lot more content on our website at elucidatenow.com, and give us a call if you have any questions. Thanks.